Example 1 on lesson 72, it's one of these experimental graph problems without the line already drawn for you. So what's different from what we did before is the line's not already drawn for you. That's the bad news. The good news is you can draw the line yourself, and that allows you to put it in specific spots so you can kind of pick some nicer points where before you kind of had to ballpark some maybe estimated points like 40.1 comma something. Now you can go right on things. Just keep in mind that the chances of being right by the back of the book at this point, right by the back of the book, is very slim. The chance that you pick the exact same 2 points they did is very, very slim. So once again, show me no work and give me an answer that matches the back of the book answer. That gets you -6 because you didn't do it, and you're wasting my time. So any line that fits the trend of the data will be sufficient in my book. All right, so let's say that I think it looks like this. That line's good because you know that fits the data, right? It's kind of trending. That line also seems reasonable. This not so much, right? That one not so much. You know, you kind of want to be in between the data points somewhere. And what I'm going to do is I'm going to put it so it hits right on some nice friendly points. So right there and right there, if I draw that line that connects those 2 points, it seems to fit the trend of the data, which seems to be increasing as it goes up. Another thing to consider again, be careful with this. If you count down by the scale going on, 200 down 40, it's skipping 2, so it's actually down 20. So 180, 160, 140, 120, 100, 80, 60, 40, 20, 0. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. This is actually 0, 0 down in the corner. It isn't always 0, 0 down in the corner. So be careful of that when you're identifying coordinates, that you know what the bottom and the top and the left and right sides represent based on the scale you're using. So, looking at the 2 points, I'm going to use some different colors. This red point down here is 40x0y. And let's go with a black dot up here. That's right here, 160x10y. Okay, those are the 2 points I would pick. Okay, if you picked 140 comma 10, I couldn't say you're wrong. Okay, because again, if you picked 100, like so, let's say you picked the same point here and came up to here. Both those lines look like they fit the data pretty well, so I'm not going to argue with either one of those. All right, just give me the right answer for that, and for my sanity's sake, please, decimal answers on these problems every time, 100% of the time. Never ever give me fractions on these problems. So, once I get my 2 points, and it's just slope-intercept structure, right? I'm going to find the slope first. Y minus y on top, x minus x on the bottom. The order of subtraction has to match top and bottom, so I started with 0.2 on top, started with 0.2 on the bottom. 10 minus 0 is 10, 160 minus 40 is 120. 10 over 120 is like 0.0833. Is that what you guys got? 0.0833?
Yes.
Is that right?
Yeah.
Really good guess.
1/12, so yeah, that should be.
112.08. Yeah, excellent.
Should be right.
All right. So the slope is 0.0833. And once I know what the slope is, now I want to find the y-intercept. I go back to one of my 2 points. Doesn't matter which one. I like this one because it has a 0 in it. Y equals m times x plus b. So if I do 0.0833 times 40, I get 3.332. So move the 3.332 over to the left, I get b is equal to negative 3.332. Okay, I'm fine with a couple decimal places in the final answer, so I won't bore in my work, right? So, and the y-coordinate here is salt, the x-coordinate is carbon. So, and it says salt is a function of carbon, so they want to use the letters S and C. So S equals slope 0.08 times carbon plus y-intercept. And just like that, I get a pretty good graph. Right? That's what we're doing now. There is a best answer to this problem, and when we get to geotrig, we'll learn how to find the best answer to this problem. It would involve knowing the actual data points coordinates, and there's called a linear regression. Your calculator has the ability to do that. But keep that in mind that there's a best answer. What we're doing right now in this class is just getting an approximate answer. And again, you have to, on your paper, show me the points you used. All I do to check these is I verify those 2 points make a decent line for the data. Then I verify you get the correct answer for those 2 points. So basically, for every student I have to work out the problem. You pick the 2 points, I verify the points are good, then I verify you got the right answer for the points you picked. The chances of anybody getting the same answer as anybody else on these is slim. That one, I mean, I could believe 2 people pick those 2 points, but as they get a little more elaborate, the chance of picking the exact same 2 points as somebody else is very slim. One last thing I do want to remind you of, the further away you pick the points from each other, the closer you are going to be to a good answer. Like if I was to go, I don't know, let's say with this point and this point, you know, and I'm estimating the position of those, if I'm off by a little bit here, you know, all of a sudden it's a lot steeper. So by spreading them out, you're preventing some error to that answer. So pick points way far away from each other. That gives you a much more accurate answer when you do it.